Hello everybody, and welcome to today's session. In this session, we will be talking about load balancing Azure virtual machines using internet-facing load balancer. Although this session will be based upon how load balancing works in Azure, what exactly is a load balancer, what exactly is Azure load balancer, and how exactly we configure the load balancer in Azure. So this will I'll show you quick details of how to set up things, how to configure the load balancer in Azure, what all are the types of Azure load balancers, what type of load balancers are available in Azure, what are the offerings, and we'll have a quick demo on that also, and we'll also talk about the pricing here. So let me introduce myself to you. My name is Karan Meet Singh, and I am working as a technology evangelist in Canvas Automations Private Limited. So I have a considerable amount of experience in handling much of Azure and Enterprise Mobility Suite, that is EMS deployments. So I have been, helping different organizations, various number of organizations, in following the Microsoft's cloud first, mobile first strategy. So uh, in this particular session, since we'll be talking about load balancer, so I will try to make it as simple as possible for the audiences who are very new to this particular thing, who are even listening this thing for the first time, because it might happen that many of the audiences here, they might be they might plan to buy Azure offerings, or they might be new to what exactly Azure is, or how exactly to play around with Azure. So for that particular reason, I will quickly show you how to set up things also. So let us move ahead with the what exactly is load balancer. So I'll take a simple example of a website. We can take an example of a website, an e-commerce website, right? So what happens is, take an example of a scenario where suddenly the inbound load towards the website increases. That can be a Thanksgiving Day, or that can be Christmas Eve, any type of festival, or any type of any eminent day it could be. So the spreads that are incoming, the incoming spread requests that are coming to the virtual machines, or your web server, or whatever it is, so that increases. So it actually becomes very difficult to distribute and handle that type of load. So load balancer helps you in that particular scenario, where you can spread the incoming requests to the multiple servers to handle all your load. So when we talk about load balancer, so basically we try to assume that most of the VMs, whatever the VMs that we are trying to load balance, are serving the same purpose. So since I talk about that e-commerce website, in this particular scenario, all of the VMs are serving the same purpose, but the only difference is these are the different instances, and since the load is much heavier here, and the number of incoming requests is it's quite bulky, so we are trying to simply divert all the requests to multiple servers randomly here. Now let us talk about what exactly Azure load balancer is. So when we talk about load balancers, there are different type of load balancers. It could be software level load balancers, hardware level load balancers, and mostly in this particular era, software level load balancers are used because they are much cheaper and much easier to configure. Whether be it any kind of server you are using, you can simply if I talk about modern era scenario, what IT pros used to do is they'll simply install their Windows Server 2012 R2 in these days, and they'll simply configure the role, the load balancing, and everything is it's and it's done, right? But what exactly the pain is for the IT pro is he has to install that particular operating system on a host, and then he has to configure the networking, and there are many other things, and then he has to meet the business requirements. uh, uh, it's the issue regarding, there are a lot more issues regarding scaling up, scaling down, when we talk about the business requirements. So it actually becomes the pain in the head. So what exactly load balancer, Azure load balancer does is, it is a layer 4 TCP UDP load balancer, so which helps in delivering high availability and optimum network performances to your business applications. So uh, so it distributes your traffic among healthy services. It distributes all your traffic towards healthy services. When we talk about healthy services, so this is, you can call Azure Load Balancer as an intelligent, load balancer. It understands the, the health of the services running behind it. So let us take an example here. So when we talk about healthy services here, obviously, in a business scenario, it might happen that, some of your if there are multiple virtual machines, multiple hosts that are load balanced, and they are, serving the same purpose. Let us take an example of that e-commerce website itself that I was talking about in the previous slide. So what exactly happens is, imagine, there are a number of instances. Let us take instances of the virtual machines are running that serves the same purpose, that serves the front end of that website. Now imagine two of the instances are down for a particular reason. That could be, unhealthy operating system, or, a server damage, any hardware failure, or any kind of scenario it is. So your the load balancer which, you use, it might not be, you can say, intelligent enough to understand, okay, these services are not running, let us, not uh, distribute traffic towards these services, because obviously it is going to show me an error in that scenario, and the users at the other end, the clients at the other end that are accessing those, those websites, they will simply be provided with an error scheme. That is not what I want, right? So in that particular scenario, you can distribute traffic among healthy services. By healthy services, I simply mean here that all the traffic, it will only be routed towards the services that are up and running. If there is any error with the virtual machine, it is not running, it is not available, it will simply not transfer requests, it will not distribute traffic to those unhealthy services. So why exactly do we use Azure Load Balancer here? So we will be talking about this also. So basically, there are different type of load balancer offerings available here in Azure Load Balancer. So when we talk about Azure Load Balancer, the first thing that comes to my mind, obviously, uh, and we will also be having a demo on this particular specific thing. Since this session will be, concentric towards internet facing load balancer, I'll, explain and show a demo regarding specifically on internet facing load balancer. But for, more understanding, for more presentation, I will try to keep it logical enough to understand different offerings of load balancer that Azure offers, right? So the first thing we talk about here is, it will be internet facing load balancer. So you can, for the internet facing load balancer, as of now, what you can imagine is, a few of your workloads are, a few of your, business applications are running in Azure. That could be Azure websites, that could be Azure virtual machines, or that could be Azure cloud services. For the people who don't understand what exactly is cloud service is basically a logical grouping. It is a logical name where all of your virtual machines are residing, where all of your websites that are residing. So now, since more and more updates are coming, we are usually moving towards Azure is usually moving towards Azure Resource Manager model, which includes these new things like Azure websites, and bypassing what we earlier used, that was Azure cloud services. So many of the things, there are a little differences between Azure websites and Azure cloud services. You'll find, according to your business requirement, you can always choose between those kinds of offering. So let us move ahead with what exactly we were talking about, right? So we're talking about internet facing load balancer. So we can talk, we can say a few of the workloads are running in Azure, right? And it is being directly accessed by the clients that are outside of that network, or you can say outside of the Azure data centers. So requests are coming directly into the virtual machines that are residing into the Azure data centers. So in that particular scenario, an Azure endpoint lies at the boundary of Azure data center. So when we talk about internet facing load balancer, that is it. We'll also be having a quick demo on that, so don't worry. Moving ahead, we'll be talking about internal load balancer. We call, in short form, we call it ILBs. So in that particular scenario, according to your business requirements, what you can actually set is you might be inside a network, or your application, it is accessing a database tier at the back end, right? So multiple requests are coming to your database tier, and you are using, multiple number of instances for that database tier, and you have set up replication between those database virtual machines, or database services. So in that particular scenario, using the internal load balancer, if you're not publicly exposing your particular database, you want it for internal configuration, you want it to be used inside a particular virtual network, you can use internal load balancer to do the load balancing internally. So moving ahead, now this is our traffic between cross-premise virtual network. So this is one of the interesting scenarios, which many of the customers have, put a question towards me. So how can we actually, load balance the virtual machines that are residing at my own premise and on the Azure data center? So you can always set up, load balancing between the virtual machines that are residing cross premises. So yes, you can definitely have a scenario here in which your virtual machine is inside your data center, inside your own company, inside your own premises, and some of the virtual machines serving the same purpose are at Azure data center. So you can set up VPN connectivity between your premise, or you can set up site-to-site connectivity between your on-premise, your premise that is running the virtual machines, and the Azure data center, and you can load balance things in that way also. And then when we talk about forwarding external traffic to a specific VM, that comes to the rescue when we say, okay, the five number of virtual machines that are load balanced, that are in a load balance set, they are serving the same purpose. Now imagine if we want to, slowly and slowly we want to upgrade those. The operating system might be, that could be that might be upgrading the applications, that might be upgrading the operating systems, the patching, the updates, any kind of scenario. So in that particular scenario, you can always have that kind of setup in which you can specify to which particular set of virtual machine, to which particular individual virtual machine you want to forward the requests to. So during that period of time, you can always shut down some of your virtual machines that are not being publicly exposed, and you can always continue to serve the requests to the virtual machines that are you can say idle, or that are not being updated, or that are not being played with. So when I say Azure load balancer, so this is truly not a rocket science. It is it's simple to configure, it's easy to use. At the back end, a minimal a very easy setup is being done. So when we say Azure load balancer, the one thing that comes to my mind is it's hash based configuration, right? So as you can see in this slide, clients are trying to access the Azure load balancer here, and the requests are routed towards the virtual machines, right? So in the first phase, you can say connection 1 is built up here. The Azure load balancer basically uses a five tuple uh, five tuple hash to map traffic to available servers. So these five tuples include source IP, source port, destination IP. By destination IP, I simply mean the cloud service virtual IP, or the public IP, and then the destination public port, and afterwards the protocol that is being used, whether it is HTTP protocol, uh, TCP protocol, whatever it is, right? So as you can see in this slide, connection is being built with Azure load balancer, right? So what happens is, as I say, packets in the same TCP or the UDP session, those packets will be directed to the same data center IP instance. So packets in the same TCP or UDP session will be directed to the same data center IP instance behind the load balance endpoint. So as you can see, connection 1 is built up. During the time that connection is there, the request from that particular client, that particular IP address, that particular source will be transferred to only virtual machine 1 till the time connection is established. After the connection is not there, the source port changes, and then this may cause the traffic to a different data center IP endpoint. So in one way or the other, you can say that yes, there is a little bit of sticky sessions over there, IP affinities over there. So other things include Azure Load Balancer features is the port forwarding. Now this is in a good scenario where we can give control to manage the inbound communication. So this communication can include traffic that's initiated from internet hosts or virtual machines in other cloud services or virtual networks. So this control is represented by an endpoint called an input endpoint. So what happens is an endpoint listens on a public port and forwards the traffic to an internal port. You can map the same port for an internal or external endpoint, or you can use a different port for them. So that is not the problem here. For example, you can have a web server configured listen to port 81 while the public endpoint mapping is port 80. So you can always make sure that okay, internally my IIS or that web server that is on which the IIS is installed, it is listening to port uh, the internal port, the private port is port 81, and outside the port 81, 80, port 80, HTTP port is mapped to this particular endpoint. So creation of public endpoint triggers the creation of an Azure load balancer instance. Now, one more thing that I like about Azure Load Balancer, it's automatic reconfiguration. So Azure Load Balancer, instantly reconfigures itself when you scale instances up or down. So when we talk about traditional load balancer, what exactly happens is you install new virtual machines. You have to, again specify to the load balancer, okay, this set is the new set of virtual machines which I have added in my load balance configuration. So there are, numerous configurations that you have to do and many other things you have to do, right? So it again, it again acts as a pain in the head. So what Azure Load Balancer gives you, it everything is automatically reconfigured. For example, this reconfiguration can happen when you increase the instance count for the web role or worker role of your Azure cloud services, or when you put additional virtual machines under the same load balance set, everything is automatically reconfigured, everything. Yeah. So one more thing about Azure is the load balancer is it's the service monitoring. So Azure Load Balancer offers this capability to probe for health of various server instances. By probing for health, I simply mean that okay, uh, I have 7 to 8 number of virtual machines in one load balance set. I have published this website or this load balancer IP address, or you can say my DNS name attached to this load balancer IP address. Now whenever the user is striking that endpoint, whenever the user is typing that URL on of that website, so they'll only be directed towards the traffic will always be routed to the virtual machines that are always up and running. They will not be routed towards the virtual machine that are shut off. So Azure Load Balancer will simply distribute the traffic only towards the healthy instances. So what exactly it does is it uh, constantly and repeatedly probes for help. It will send the triggers, and if the acknowledgement is received in the specified time period, it can say yes, the virtual machine or the service running behind the endpoint, it's running. But if after a certain interval of time there is no reply from the service, it will stop sending connections. The load balancer will stop sending connections to those unhealthy endpoints. So these are some of the scenarios that Azure Load Balancer offers to you, which I am just showing what I have already spoke about. Internet facing, this scenario is internet facing load balancer, where as you can see in this image, so client sitting at his home, he's accessing an HTTPS website, and his request is uh, routed to the load balancer, that particular IP, that load balancer instance. So this load balancer endpoint resides at the boundary of Azure data center. So inside, you can say 3 VMs serving the same purpose are running. So load balancer distributes everything to these particular virtual machines. And as shown in the figure, it's exactly the same. Nothing, it's not required to set up a different virtual machine as a as a load balancer VM, or you just have to, with the click of few buttons, you can have your load balancer up and running. No need to set up a virtual machine, no need to specify uh, in that virtual machine as a base virtual machine and then some other IP address of the load balance set in that virtual machine. Nothing is required. You just need a service. There will be a service portal, which I am going to show you in a few minutes, in which you will be specifying the set of virtual machines you want to be load balanced, and everything will be done in just a few clicks. So one more scenario that comes into existence here is internet facing multi-tier application. So this can be a scenario, the business scenario, what you might be looking for exactly. So the scenario which we were earlier talking about, it was a very simple scenario, and we can say, okay, this is just the front end, nothing is, a static website, or we can say a database that is static, and no configurations are running in the backend, no database, no, not high-end applications we were talking about earlier. Now we are talking about a proper business logic, what exactly your organization is trying to do. So here you can see the client end at the client end, the user is trying to access a particular website. So as you can see, this dotted boundary, the blue dotted line as outside, you can see this is basically a cloud service. So for the people who don't know what exactly a cloud service is just a logical grouping of your virtual machines and all your services that runs in Azure. So in the cloud service, you can have your virtual machines also, or you can have your database also, and PaaS offerings also. Everything you can get an amalgamation of everything under a single cloud service. So user is trying to access this website. Okay, so he puts the DNS name, and that is routed to that load balancer. So load balancer here is load balance is distributing the request to the virtual machines, different virtual machines, but at the back end, this web tier is also accessing a database tier also. What happens is multiple requests are being sent by this web tier. So you can take an example of a simple e-commerce website here, or you can take an example of a static database here that is trying to access the web front end, that is trying to access similar type of database. And since the load is quite high, so we have increased the database instances to 3 here. So at that point of time, you can have an amalgamation of public load balancer, that is internet facing load balancer, and an internal load balancer that is not publicly exposed. So as you can see, port 1433, so this internal port is being mapped to the web tier. So your front end virtual machines can always get the load balance configuration of the database tier. So when we talk about intranet line of business application, so this is basically a scenario which I talked about in just the beginning. So I was talking about many of the customers that have approached me, and they've asked, okay, we want such a scenario in which my on-premise server is inside the same virtual network where my virtual machines are residing. So how can I actually load balance getting inside the Azure data center, or getting inside that virtual network? So in that particular scenario, you can always set up a VPN connection. So you don't need to set up a particular, you can say, internet facing load balancer in that scenario. What you can have is you can create an internal load balancer there which is not publicly exposed, and you can always get connected to that cloud servers to that line of business servers using that VPN connection. So in future sessions, I'll be covering every little bits and bytes of these things also. But since this is a session purely based on internet-facing load balancer, we'll have a quick demo of what exactly internet-facing load balancer is. So I'll quickly minimize this, and I will go to my Azure portal here. Just give me a second. Portal.azure.com. Yeah. So as you can see, it's visible there. So let us try to access my Azure portal here. I'll write my credentials, which I'm not going to tell you. Sorry, my bad. So now I am going to be authenticated to my Azure portal. So let us see how exactly we configure load balancer. Okay. So these are the set of virtual machines. Yeah. So this is my virtual machine 1 and this is my virtual machine 2. And using RDP, I have connected to, I've already done this scenario. I have connected to these two VMs, and I have set up, let me quickly, okay, they're already running, right. So let us try to access this particular IP address. So let me copy down this IP address, and I'll paste it here. Yeah. So this shows that, oh, sorry, this looks ugly, but anyways, for this demo purpose, I didn't have much time to set up many of the things, so I simply used Microsoft Paint and painted this in such a bad way. Right. Anyways, leave it. So this is my IIS homepage, right? So this shows that, okay, this is my virtual machine 1, the first virtual machine, so which is publicly available, and this is my virtual machine 2, which I've already configured IIS again. And let me copy down this. I'll paste it here. Okay. So yeah. So again, ugly picture. So yeah, this is virtual machine 2. So this is the public IP of virtual machine 1. This is the public IP of virtual machine 2. So both of these websites are publicly available. Now in this demo setup, I'll imagine they are serving the same purpose. So what we can do is we can set up a scenario where our users are striking a particular IP address, not this IP address, not even this, and not this also, a different IP address, and all of these requests will be routed to these virtual machines. So you will not be using any of these two public IP addresses. You'll be using a different public IP address that will be the IP address of the load balancer here. So let us see how to set up things here. So I'll click on browse here, and I will go to load balancers. So in this scenario, I have already created this load balancer. So what I'll do is I'll delete this for you. Let me try to delete this. And I'll quickly try to create a new one. I wish this should be created within the specified time. It will take a couple of minutes. Yeah. Just taking a little bit of time. Loads balances again. So yeah, so till the time being it is being deleted, let me go back to the pricing of load balancer. Then I think I'll simply come back to how exactly we configure the Azure load balancer. Okay, so yeah. Yeah, so since I was talking about the pricing, don't worry, I'll be coming back to the demo itself. Just give it a little bit of time to delete the configuration that I had already done for this demo setup. So let's talk about pricing here. So yes, what you are looking at your screen, that's perfectly correct. So Azure Load Balancer, it gives you public load balancing and internal load balancing for absolutely no charge. You don't have to pay anything, be it any number of virtual machines you use in that cloud service, you use in that resource manager model. Uh, Anything you use, it is totally of free. But there is just one prerequisite which you have to complete. So in that particular scenario, you should always use the standard virtual machine. So there are basically different types of virtual machines in Azure. You have standard, premium, and basic virtual machines. So we cannot use load balancer with basic virtual machines. If we can set up load balancing with standard virtual machines. So you just have to pay the price of the virtual machine or the cloud service you are using, standard service you are using, and it is absolutely free. You don't have to pay anything, nothing is charged from you. So let us go back quickly. Yeah, so coming back to the demo, as you can see, this load balancer is already deleted. Now for this demo purpose, let me create one brand new load balancer for you. So I'll quickly type the load balancer name here. So this is the name of my organization, and I'll say Canarus-LB. Since this will be a public load balancer, that is all the requests that are striking this load balancer will be from the client end sitting remotely and on the public network. I'll click the scheme public here. So now we have to specify an IP address. So you can always create a new IP address here, but since this IP address is available, I'll select this IP address. As you can see, it's LBPIP. I've already configured this. You don't need to worry about that. Or maybe I can, you can follow up the blog to how to set up exactly how to set up the load balancer. What are small bits and bytes, or what are all the prerequisites before setting up a load balancer. For this quick demo, I've already created this public IP address, so you need not worry about that. So I'll choose my subscription here, and then I'll choose my resource group. So this is the resource group. So for the people who don't know what exactly is resource group, as the name suggests, it is basically a logical grouping of the resources. So whatever your resource is, be it your virtual machine, cloud, virtual machines, Azure websites, database, IP addresses, network interface cards, anything, be it anything, it's all grouped logically into this resource group. So how resource group basically helps you is uh, for the organizations that do testing every now and then, they have to create virtual machines, they have to create virtual networks every now and then. For example, for a particular business scenario, for a particular DevOps scenario, what people do is developers create something, and then the testing create something. The environment they use, that is totally different for them. They have to again create a different set of virtual machines, and then they have to delete those virtual machines at the end, wiping up everything so that they are not being paid for what they don't use. So at the end, IT admin has to make sure that everything is deleted. The Azure admin has to make sure that everything is deleted in that scenario. So what you can do with the resource group is, with a click of a button, you can delete everything without thinking about deleting every virtual machine, every single virtual machine individually. You can delete everything at once. You can also set up tags on your services that resides in that resource group. Okay, in this resource group, these are the virtual machines, and I have tagged these virtual machines to my XYZ department, or you can say DevOps department, and this DevOps department has consumed this much of credits. They have, because of them, I am being charged this much, and they are, using it at a very high rate. So let me go and talk to them and tell them, okay, the amount of the usage you're doing, that is not right. Please bring it down, or use those resources efficiently. All these things you can do with resource group. So much of the talking regarding resource group. Let us come back to the demo. So as you can see, the location is Southeast Asia here. So this deployment is being submitted. It started also. My bad, I need some water. It's still working. We'll give it a little bit time. So meanwhile, what I was talking about the resource group, right? Let us see what how exactly a resource group looks like. So this is my resource group, and as I said, this is logical grouping of everything. So this is my virtual machines. These virtual machines are this in this availability set. This is my load balancer that I've just created. These are the network interface card of my virtual machines. This is the network interface card for the first virtual machine. This network interface card for the second virtual machine. This is public IP address for the load balancer. This is public IP address for the virtual machine one, and this is public IP address for the virtual machine. So everything is logically grouped. And when you don't require things, instead of going and clicking, delete on every particular thing, you can simply set, okay, I just want to delete this, and that's good to go. Everything will be deleted up at once, right? So coming back to load balancer again. So this is where my load balancer is. Right? So these are the properties of my settings of my load balancer. So let us see how to set this up. Okay. So at first, what I'll try to do is I will simply provide this load balancer an IP address, which I've already provided. Okay, so that is not required. Now I will provide backend pool to this particular load balancer. By backend pool, I simply mean, okay, this load balancer should be connected to some of the endpoints that are serving my business logic. That could be a virtual machines or anything. So I'll get into this, and I will add my availability set here. Okay, so I'll give it a name also. First I have to give it a name. Yes. So I'll say this is my LB backend pool, load balancers backend pool. Canvas LB would be fine. Understanding, right? And I will add this availability set in which my virtual machines are residing. So this is basically availability set, canaries AV set in which number of virtual machines are residing. So for this demo purpose, I've already created two VMs which I've already shown you. So I'll quickly select all the virtual machines which I would like to be in this load balanced set. Click on OK. As you can see, both of these VMs are added here. I'll click on OK. And let us give it a little bit time and see where it takes us. Come on. Anyways, let us give it a little bit time. And in the timing we can explore some. Okay. Yeah. As soon as I go on exploring something else, it's so quick enough to give me a success report. Yeah. Going back to that, my bad, load balancer. Yeah. So this is the load balancer, and the backend pool, it has two virtual machines which I've already specified. I've shown that to you. Then I will quickly create a probe here, as I've explained to you what exactly how probe works. So probe works in this particular scenario. For every specified interval, it will send you can say requests. It will probe the service. So I'll give it a name. This is canaries LB probe here, and it's using the TCP protocol here. It will send the TCP requests on port 80 to these services. Okay, so the interval here, for it will send those probe every 5 intervals, and after every after the 2 consecutive failure, it will declare that VM, that service to be down, and it will stop sending requests. It will stop routing traffic. This load balancer will stop routing traffic to this particular uh, that particular service. So let it be done. Refresh this and let us see it again. Still configuring. I don't know why it is taking so long. It used to take hardly 3-4 seconds. No, I'm not going to anything else now. I'm just waiting for it. Ta-da-da. Yes, so I didn't see this. Yeah, it's saying created probe, successfully created probe, canvas will be probe. So this is the probe we have created, and you can always reconfigure it, and you can make changes to it whenever you want. You can click it, and feel free to do any changes you want. Now we will specify the load balancing rules in here. Keep it on TCP. We'll name it as Canvas LB rule. So, so what it's doing is on port 80, it is mapping the backend port 80 and sending those requests to this backend pool which we've already specified, and it will be probing this backend pool every 5 seconds, and after every two, you can say, unsuccessful attempts, it will declare that service to be down. For this particular scenario, we will keep the session persistence to be none, because you're not looking for any, sticky session here, or this. As for this demo purpose, let us, keep it on none itself. It will not be playing with any IP and any protocol. And then click on OK. Again, a couple of minutes, and then load balancing will be up. It's done, I guess. It's showing me. Let us give it 1 minute more. Let's see what happens. Again, if it's taking too long. So it is still saving this configuration. Yes, so it's saying it's saved. So let us quickly go back to the load balancer configuration again and see. So since now everything has been set up, so now the time has come to do the testing here. So this was my IP address or public IP address of the virtual machine 1, public IP address of the virtual machine 2 in here. Now we will copy paste this public IP address of load balancer here. Control C on my PC and I paste it here. Control V. Let's quickly try to access this. Okay, so it is randomly taking me to the first IP address. So I'll try to refresh it. Let us see if it takes us to the second VM after the load is increased. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Do it for 50 times. So 8, 9, 10, 31, 32, 33, 34, 35. That is caching in my system. Might be that something it's not happening. Okay, this is irritating. This is actually irritating. So anyways, that might be caching in my server. Let us quickly try to open another tab. See, try to open a new connection. Okay. Okay, that is still not done. I'll open a new browser window to start a new connection. I'm opening Mozilla, right? Okay. So I'll paste that IP here. Again, it's giving me virtual machine 1. Why is that happening? It's irritating. Okay, I will try a new session. No. Let me check if my virtual machine is running or not. It might happen that one of the virtual machine is not running. Yeah, both of the virtual machines are running. That is not a problem here. So, I don't know when it will take me to virtual machine 2. Yes. So as you can see, the new connection has been established. So it is randomly routing that connection to this virtual machine. So it's taking me to virtual machine 2 from now onwards. Let us again open a session here, and it's taking me to 2. And here it's taking me to 1. So this is how a random distribution is being happened here inside Azure Load Balancer. So I guess this is all about Azure Load Balancer. So as we have already talked about the pricing here, so Azure Load Balancer, as you know, it's free of charge. All you have to make sure that you're using the standard VMs. So you can get a VM as low as uh, to one, you can say $0.04 per hour, and it's quite cheap. It is actually quite cheap. So for your business requirement, I think that is the perfect scenario if you're going to use your load balancer, because it gives you load balancer for free. You don't have to set up a virtual machine in there. And for any question and answer, any queries, what we can do is, as this is not a live session or something, you can post up your questions below in the platform here in YouTube comments, or what we can do is you can quickly DM me on my Twitter account. So you can definitely follow me on Twitter at Singh Cloudy, SINGH Cloudy. So that is my nickname, which I basically like it. So anyways, so you can quickly follow me up there, and you can see all the latest posts, all my blogs, everything over there. And for any any scenario, any personal opinions, anything, you can contact me on my business email ID also, that is karanmeet.singh. Pardon, my name is too large. So karanmeet.singh, it's too long, at ecanalys.com. Feel free to contact me, and I'll be ready to get in touch. For the next steps, what we can do is you can sign up for a free 1 month trial on Azure, and you can receive $200 worth of credits, and you can use any type of service you want during that 1 month of service. And if you're comfortable with it, which I am pretty much sure you will be, you can simply move ahead with buying or a different type of subscription. You will be getting pay as you go subscription, or different types of subscription, enterprise agreement subscriptions with some type of discounts also. So for that, you can quickly go up on this page and you can see what all are the offerings from Azure. And for this particular load balancer documentation, as I have already said, everything is being updated, so there might be discrepancy from the time you're watching this video and during the time you are actually performing the lab. So you can quickly follow this particular documentation article, in which everything is updated side by side by Microsoft guys. So I guess that is it for Azure load balancers. And again, if you have any questions, please feel free to contact me on Twitter or on my email ID. So thank you for joining me. Thank you for joining me again in this session, and have a great time. Bye bye.